The next speaker is just an absolute favorite of mine. Sara Soueidan is, yes, absolutely, an independent, inclusive design engineer from Lebanon, working with companies around the world on responsive design, accessibility, and performance. And she has a course coming up, or a course available on practical accessibility, so definitely check that out. Please welcome Sara Soueidan.
Thank you, Mia. Wow, I haven't done this in 4 years. My last in-person talk was in 2019, and that year is the year that I also spoke at CSS Day. It's my first talk in 4 years, but it feels like my first talk, period. I'm really glad to be here. CSS Day holds a very, very special place in my heart. I need to keep this introduction short because if you know me, you know what's coming up. So the title is The Other C in CSS. I know what you're thinking, like we need another C in CSS. We have enough C to worry about and to manage. Thank God for Tailwind. This talk is about CSS and accessibility. More specifically, it's a talk about understanding how the CSS you write affects the accessibility of the user interfaces that you create. Even more specifically, it's a talk about how CSS affects the semantic accessibility of HTML. Because like it or not, I know it's icky, as someone said in the comments yesterday, because like it or not, CSS affects more than just the visual presentation of elements. Its effects cascade down. That's where the cascade comes from. Its effects cascade down into the HTML and accessibility layer and can affect the semantics exposed in the accessibility tree. Buckle up. This talk is going to be practical, it's going to be technical, and it's going to be fast. Like the DOM tree, the accessibility tree is a tree of objects. Each object represents an element on the page and contains accessibility information about that element. Like, what is this kind of element that I'm interacting with? What is its name? How do I identify it? What does it do? Unlike the DOM tree, the accessibility tree is not painted into a visual user interface. Assistive technologies use the information presented in the accessibility tree to present content to the user and to create an interface for navigation for their users. Typically, there are 4 main pieces of information in the accessibility tree object that describe an element to screen reader users or assistive technology users in general. The first piece of information is the role. The role determines what an element is, which is also an indication of how that element is to be used. Most semantic HTML elements map to ARIA roles that are defined in the platform's accessibility API. The browser checks the accessibility API mappings for each HTML element and exposes the role of the element that is relevant to accessibility in the accessibility tree. Not all elements are mapped to meaningful roles, and that's why not all elements are accessible. The second piece of information is the name. An element's name identifies the element within the user interface and should help indicate what it does. Meaning that a link should not say, click me. It should indicate where it goes. The name of the button should indicate what it does. Sometimes an element may have a short description that provides more useful information to the user, like input fields that sometimes have a hint describing the type of content that is expected, the type of input. Using ARIA, you can associate a description with its element so that it's exposed in the accessibility tree. Many elements, particularly interactive ones, also have a state. For example, a checkbox can be checked or unchecked. A button can be pressed or not pressed. States respond to user interaction and must be announced to the user when a state change happens. And this is very important because we're going to come back to this at the end of the talk. All native interactive controls come with state information that the browser updates and exposes to screen readers via the accessibility tree. The browser provides interactive behavior to native interactive controls like links, buttons, checkboxes, the native disclosure widget, the details element, and it updates and exposes the state of these elements when the user interacts with them so that the user understands the changes that have occurred as a result of their interaction. This is important because without a state, a screen reader user will not know when a change has happened as a result of their interaction. An accessibility tree object may also contain element properties, such as if the element is required or disabled, and element relationships, such as if the element is part of a group or if it is labeled by another element. All this information is necessary for assistive technology users to understand the elements of a web user interface. Without them, the user interface is not going to be understandable. The CSS you write can affect the accessibility information exposed in the accessibility tree. It can affect the role, especially depending on the browser and screen reader combination. It can affect the name and description of an element, and it can even affect whether an element is exposed in the accessibility tree at all. And in some cases, it can directly impact the screen reader announcement in ways that, unfortunately, I cannot cover in this talk today because I had to delete that section yesterday. Some CSS properties may affect an element's role in certain browser and screen reader pairings only. For example, you may already be familiar with this one. Some older versions of Safari on macOS will remove list semantics when you remove the default list markers. When that happens, VoiceOver no longer announces the list nor the number of items in that list. This could degrade the user experience if the user benefits from knowing how many items there are in the list, such as if you have a navigation, especially a large one. A user will benefit from knowing how many items there are in that navigation. Otherwise, they're going to start browsing through it endlessly, seemingly endlessly. Newer versions of Safari, specifically starting with Safari 16, will also remove list semantics unless the list is contained within a navigation landmark. If the list is contained in the navigation landmark, you can remove the bullets and numbers, and it's not going to remove the list semantics. I'm guessing the browser assumes that if the list is in a navigation, then it is important, and so we want to keep those semantics. This behavior was reported as a bug before a WebKit engineer, James Craig, explained that this bug was in fact a purposeful change to improve the screen reader user experience because a lot of developers due to rampant listitis of web developers, overuse of lists, just like we used to have divitis. As Craig mentions in his comment, you can reinstate the list semantics if it is beneficial for the user to hear the start and end of a list and the number of items in that list. And you can do that by using the ARIA role attribute with the value list. Then, to ensure that the list semantics are not removed when you style your lists, this is one of my favorite ways to use ARIA attributes. You can use the list role as a semantic styling hook in your CSS. By tying the list style declaration to the list role, you ensure that the list markers will only be removed on lists that have their semantics reinstated in the markup. Or you could avoid stripping the lists of their semantic roles altogether by using list style type instead of list style and setting it to an empty string. Manuel Matuzovic has shared that using list style type with an empty string prevents list semantics from being removed in Safari like list style none does. Now, whether you use list style type or stick with reinstating semantics in HTML using ARIA, always make sure that you fire up a screen reader and test, because you never know when browsers apply new heuristics that change how an element is going to be announced by screen readers. Make it a habit to fire up a screen reader, get used to the shortcuts. It's really fast, it's really easy. Walk through the page and just listen, see how it's announced. Is the list being announced or not? CSS can also completely remove the presence of an element from the accessibility tree. Now, there are several ways that you can hide an element using HTML, CSS, and ARIA. In CSS, there are 7 main ways that you can hide an element on the page. Out of these different ways or techniques, visibility hidden and display none remove an element from the accessibility tree and make it inaccessible to all users. Screen reader, keyboard, all users. Now, display contents at the bottom, on the other hand, it does more than it is supposed to do. So the purpose of the display property is to control the type of boxes that an element will generate. When the value of the property is none, you're telling the browser to generate no boxes for the element or any of its descendants. So it's neither the element nor the descendants are being generated. They're not accessible. They're excluded from the accessibility tree. Display contents is similar to display none in that it will prevent the element itself from generating a box. But unlike display none, it has no effect on the element's children. The children will still generate boxes and will not be affected by the display set on their parent. And display contents does not affect the semantics or accessibility of the element. It does not remove the element or any of its descendants from the accessibility tree. Well, at least this is the intended behavior described in the specification. The reality, however, is different. Display contents has a long history of bugs and accessibility issues across browsers that has made it practically unusable over the last few years. Today, most browsers have fixed many of the bugs with display contents, but there are still some remaining ones. And Adrian Roselli has documented these bugs along with links to their open issues in a very comprehensive post that I highly recommend you check out. Jonathan Schofield on Mastodon also recently shared, not on Twitter, recently shared that in Firefox, using display contents completely breaks the anchoring effect of an ID attribute attached to an element. In other words, a link to an element with display contents, if the element has display contents, the link to that element is broken. Display contents has been so problematic and buggy that inclusive design advocate Eric Bailey even wrote an article considering display contents to be harmful. So probably the only unproblematic way to use display contents today is to use it on a meaningless generic container like a div, because in that case, you are not sacrificing any semantics. Until all browser implementations are fixed, avoid using it on meaningful and interactive elements. If you write CSS and you care about accessibility, then you are most definitely familiar with the visually hidden utility class. It's a tongue twister. The visually hidden utility class is sometimes also commonly known as SR only. SR only is short for screen reader only, but since accessibility APIs describe web content to other assistive technologies, not just to screen readers, visual hidden is a more appropriate name. The visual hidden utility class allows us to visually hide an element while making sure it remains accessible, because there's currently no native way in CSS or in HTML to do that. What the utility class does, in order, is it shrinks the element to a 1-pixel square, hides any resulting overflow, clips it to remove any visual trace, such as any background colors, removes it from the page flow so it does not affect the layout flow of surrounding elements, and it prevents the text wrapping inside of it to ensure that the text is properly announced by screen readers, because when text wraps into like 1 character per line, it's not announced as it's supposed to be. The result is that the element will only be accessible to assistive technology users. And if you want to dig deeper into the ins and outs of this utility class and understand why it works the way it works and what each declaration does and why, I highly recommend this article on the Paciello group blog. Now, the not focused, not active part of the selector indicates that these styles will only be applied to the element when it is not focused or activated. This is important because you will find the visual hidden utility class in the wild without this part used on different elements. It's fine to use it without this part on text elements, but this part is important because it emphasizes the importance of not using the visual hidden utility class on interactive elements unless these elements become visible when they receive focus. Because interactive elements should always be visible when the user interacts with them. Otherwise, you create a WCAG violation, basically, and usability problem. I mean, you're focusing on something you're supposed to be interacting with and you can't see it. Now, for example, you may use the utility class to temporarily hide in-page skip links and show them when they receive keyboard focus, like the developers at IKEA do. This is one of my favorite examples of skip links on the internet. The IKEA shopping page contains multiple in-page skip links that improve keyboard user navigation by allowing keyboard users to skip long listings and jump straight to the next ones until they reach the one that they want to explore. And the skip links are hidden using the same visually hidden styles used in the visually hidden utility class. So they are visually hidden, kind of using the utility class. And when they receive focus, they become visible. Don't use the visually hidden utility class to permanently hide interactive elements. You generally don't want interactive elements to remain hidden when they receive keyboard focus. But there is one use case I can think of where you do want the element, an interactive element, to remain hidden even when it receives focus, because you have visually replaced it with an image that is supposed to replace it. For example, you may want to create an animated checkbox like this one, which utilizes the SVG line drawing technique. While we have more control over styling native checkboxes and radio buttons today, we are limited by how much of it we can style and to what extent what kind of animation. We can't even do these kinds of animations using CSS on native checkboxes. So to create animated effects like this one, we still need to work our way around this limitation by hiding the native checkbox and then replacing it with an image and animating that image instead when the checkbox is interacted with. There are many accessibility considerations to take into account when creating custom-styled checkboxes or radio buttons or other native form controls that I have documented in this article on my blog, including why you should use inline SVGs to replace the checkbox and how to style the SVG so that it adapts and remains accessible in forced colors modes. For the purposes of this talk, I want to talk I want to focus on not on the image replacement, but on the checkbox itself and how to hide it in a way that ensures that it remains accessible to all screen reader users. And by all, I don't mean different screen readers on different platforms. I mean different screen reader users who use their screen readers in a different way. Now, in addition to CSS, this is another table. It's exactly the same as that one, I think, but now with the additional HTML and ARIA techniques. There are other ways you can hide elements, not using CSS, but using ARIA and HTML. And each hiding technique affects the accessibility of content in a different way. Some of it hides it from the accessibility tree. Some of it removes it from keyboard focus. Some of it hides it visually. Depends on which one you use. For our checkbox, we want the checkbox to remain accessible to screen readers because the SVG only replaces it visually. SVG is an image at the end of the day, so you still want the actual checkbox there. And since the checkbox is going to be accessible, we can and should hide the SVG image from screen reader users because it is redundant. And to hide an element from screen reader users only, we use the ARIA hidden attribute. This will remove the SVG from the accessibility tree. Now, with the SVG hidden from screen readers, we now want to hide the checkbox visually while keeping it screen reader accessible. There are two common approaches to hiding the checkbox that you may think of right away. The first one is using the visual hidden utility class, but without the part of the declaration that shows it on focus, because you want to hide the checkbox permanently. Or by moving the checkbox outside of the viewport area completely. Both of these techniques accomplish the mission of hiding the checkbox visually while keeping it screen reader accessible, but neither of these techniques is inclusive of mobile screen reader users navigating by touch. Screen readers on Android touch devices give users multiple ways to navigate a screen. One of these ways is exploring by touch. This means that some Android screen reader users will literally move their finger across the screen looking for interactive elements. If you hide an interactive element using the visually hidden utility class, it becomes so tiny that it will be impossible to find by touch. And as you can imagine, if you move it outside the viewport, it will no longer be there for the user to find either. So how do you hide the checkbox? Well, before I get to that part, actually, here's a demonstration. I have 3 checkboxes here, and I'm using TalkBack on Android and to see how it announces the different checkboxes. The first one is hidden using the hiding technique that I'm going to share with you in a minute. The second one is hidden using the visual hidden utility class, and the third one is moved off canvas.
Double tap to activate. Refresh button. 5% progress bar. Chrome. Coded 32%. I am accessible by touch. Check. I am accessible by touch. Checkbox. I am visually hidden with utility class.
Doesn't announce the checkbox.
I have been moved off canvas.
Doesn't announce the checkbox either.
I am accessible by touch. Check. I am accessible by touch. Checkbox. Double tap to toggle.
To ensure that the checkbox can be found by touch, you need to make sure that it is still physically there, present where it would normally be present. Technically speaking, this means you should remove the checkbox from the page flow using position absolute so that it doesn't take up any unwanted space visually, and position it on top of the image that is going to visually replace it. Optionally, you can also set dimensions on the checkbox, which is really cool because you can make it bigger. And then you simply visually hide it by setting its opacity to 0. So the image that is visually replacing it becomes visible. The SVG itself is visually hidden, but it's still there. And if a user navigates by touch on mobile, they can find that checkbox. And this is how you make it accessible. Use the same technique for any native interactive control that you need to hide and replace with an image. So if anyone tells you to just use the visually hidden utility class to hide interactive elements, remember that that is an oversimplification and overgeneralization. Decide on whether or not you want to use it based on whether or not the interactive element will become visible when it receives focus. CSS can influence the accessible name of an element. So when the browser needs to determine the accessible name of an element, it uses an algorithm called the accessible name and description computation algorithm. The too long didn't read of this algorithm because the specification is really a pain to read. It looks like this. So when the browser needs to determine the accessible name of an element, first, it checks whether the element has an ARIA labeled by attribute. If it does, and if the ID in the attribute is a valid reference to an element on the page, it uses the referenced element's computed text to provide the accessible name for the element that aria labeled by is used on. Otherwise, if aria labeled by is not present, it checks if the element has an aria label attribute. And if it does, it uses the value of aria label as an accessible name. Otherwise, if no aria labeling attributes are used, and unless the element has been marked as presentational using role presentation or role none, in which case it does not accept the name anymore. So if an element has role presentation or role none, you can't give it an accessible name anymore. The browser then checks if the element can get its name from an HTML attribute, like the alt attribute on an image. There's also the title attribute, which you should avoid at all costs. There's only one useful use case for it, which is to provide an accessible name to an iframe. And the reason title is the best way to provide an accessible name to an iframe is because it is the only way that currently kind of guarantees an announced accessible name across more screen meters. Other than that, avoid using the title attribute on every other element. If the element can get its accessible name from another element, like an input that gets its name from a label or a table that gets its name from a caption, it checks to and uses that. Or if the element can get its name from its contents, like a button or a link, it uses the contents. So ARIA takes precedence over native HTML methods in the accessible name and description computation algorithm, the mouthful. Now, most HTML elements can get an accessible name in more than one way. You can use aria labeled by aria label, use the contents. It's a fun trivia. I have a fun trivia, but if I say it, I might be risking going. I'm going to say it. Did you know that the button element is a labelable element, which means that you can give an accessible name to the button using aria labeled by, using aria label, using its contents, or using a label element. But you should probably not do that because if the user is using a virtual cursor to navigate the page, then the screen reader is going to announce the label and it's going then to announce the button. So you end up with two announcements for the same element, which is not ideal. And depending on how you use it, and I can't think of a single use case for this, depending on how you use it, you run the risk of violating success criterion 2.5.3 label and name. Thank you. So most HTML elements can get an accessible name in more than one way, and the browser checks which one is used. And if more than one is used, because that happens, because developers, a lot of them, don't know how ARIA labeling attributes work, so you'd have a button that has a fine label, text inside of it, and they still throw an ARIA label on it. The browser needs to decide which one of these wins and uses that as an accessible name. Since different HTML elements can get their accessible name in different ways, the algorithm looks different for each element depending on the type of that element. That's another tangent I'm not going to get into. You can also see the order of priority in the accessibility panel of the DevTools. The browser lists the different sources that an element can get its accessible name from in the order of priority defined in the accessible name algorithm. So if you have a button, if you inspect the button, you can see that it shows you that the button can get its name from a label element. And just like with CSS properties, the browser also shows you when a name was overridden by another one. For example, if you have a button that has a perfectly fine label inside of it from its contents, but you decide to throw an ARIA label on it, the browser is going to use the value of ARIA label instead of the contents, and it's going to show you that it did that. This is the order of priority that the browser follows to compute the accessible name of an element. Since different methods can be used, ARIA takes priority over HTML, and different HTML methods, they also have an order of priority. The browser needs this algorithm to determine an accessible name. However, the order of priority defined in the accessible name computation algorithm does not define the order of priority that you should follow when you provide an accessible name to your elements. In fact, when you provide an accessible name to your elements, your order of priority should be almost the opposite of the steps in the accessible name computation algorithm. In other words, when you provide an accessible name to an element, use HTML content. If the element can get its accessible name from its content, like buttons and links, use HTML content. Use that. Otherwise, if the element can get its accessible name from an attribute, like the image element, or from another element, like inputs and labels, use that. Otherwise, if it can't, like if an example of that is a section elements cannot get their accessible names from their content or from attributes, title excluded, you should not be use it. So in that case, you would use aria labeled by and reference an element that is already present on the page. Otherwise, when none of the previous methods is feasible, then if you absolutely have to, use aria label. So prioritize native HTML. Unless providing a name for an iframe, avoid the title attribute completely, and aria should be your last resort. If you can provide an accessible name using an element's contents, like with a link or a button, do that. According to the accessible name and description computation specification, when an element's name is derived from its contents, the browser must include the contents of the before and after pseudo elements in the accessible name. A lot of you already know that. This means that any content that you add to an element using the before and after pseudo elements could and probably will be announced by screen readers, depending on that content. And depending on the content that you add, you may degrade the spoken experience for screen reader users. For example, suppose you're using the CSS pseudo content to prefix certain links with the eye icon, which is an example that I'm borrowing from the WebKit blog, to indicate that the link leads to more detailed information. The browser is going to include the icon itself as part of the accessible name of the link and expose it to assistive technologies via the accessibility tree. Then if you fire up VoiceOver on Safari and navigate to the link, this is how VoiceOver will announce the name of the link.
VoiceOver on Safari. Reload page. Latin small letter I CSS generated content. Link.
Latin small letter I. Perfectly meaningless. VoiceOver announces what the icon is, not what it represents. Though ideally, the icon should be announced as what it represents, which in this case is information. Like HTML images, icons or other non-text content inserted via CSS should be described to assistive technology users using alternative text. This ensures that the icon conveys the same information to assistive technology users that it conveys to sighted users. Of course, assuming that you're using an icon that is understood by all users, they know what that icon actually represents. Now, the good news is that the CSS generated content module level 3 defines new syntax that enables us to add alternative text to CSS generated content in the CSS content property. According to the specification, content intended for visual media sometimes needs alternative text for speech output or other non-visual mediums. The content property thus accepts alternative text to be specified after a slash. If such alternative text is provided, it must be used for speech output instead. So going back to our info icon, the code would look something like this. You have the icon, and you follow it by a slash, followed by the text alternative that describes what the icon is, what it represents. Or alternatively, you might want to reference an external image using the URL function and also give it an alt text after the slash. Then if you inspect the content of the link in the DevTools, you will see that Chrome exposes the alt text of the icon as part of the accessible name of the link, resulting in a more meaningful name and a better user experience for screen reader users. Browser support for CSS alt text isn't quite there yet. Firefox currently does not support the alt text syntax at all, and the presence of the alt text invalidates the entire declaration. No icon is shown at all. However, the good news is that Firefox support is coming underway, as I learned yesterday from Yuna, thank you, and we will soon be able to provide alt text for CSS-generated content across browsers. However, I knew you were going to get excited. There's always a however, for some reason. Accessibility engineers are always the party poopers of the conference, right? But, I mean, we mean well, really. Even though it's great that we can now provide alt text for CSS-generated content, I do not recommend using CSS to insert meaningful content that is integral to the understanding of the page. Don't use CSS for meaningful content, for several reasons. The first one is CSS-generated content will not translate via automated tools. So if you insert an image or an alt text for an image, if the user needs to use an automatic translation tool to translate the page into their language to understand it, the alt text is not going to be picked up, and the user is not going to understand the alt text. Content is only accessible when CSS is available. CSS is not always available. If the user is using, depending on the assistive technology, if the user is using the reader modes, for example, to consume the content on a page, your CSS is not going to be used at all, and so anything you add via CSS is not going to be accessible to them. CSS-generated content is not easily customizable and may become inaccessible in forced colors environments. If you add an icon, external icon, depending on the color of the icon, the background color, and when forced colors modes is enabled, and forced colors modes could be an entire talk of its own. Depending on the color theme used in forced colors mode, the icon can be completely inaccessible and visible. And when the URL references a broken image in the CSS Studio element, the alt text of the image is not shown in place of the broken image in most browsers, but the alt text still contributes to an element's accessible name. This can create an immediate violation of success criterion 2.5.3 label and name. In his article, Alternative Text for CSS Generated Content, Adrian Roselli, the man of all tests, I call him, shares the comprehensive results of testing the new CSS alt text feature across many browsers and platforms. The test page that he shares includes examples of different methods for providing alt text in CSS, regular text, URL, etc. And it even includes the proprietary Apple CSS alt property. And the page also includes broken references to images and shows what happens when the CSS image does not load versus when the HTML image does not load. So when the HTML image does not load, the alt text is shown, but for CSS, it's not. In Chrome and Safari, the alt text of the broken image still contributes to the accessible name of the element, as you would expect, but since the icon is placed at the beginning of the name and its alt text is not visible, it creates an immediate violation of that success criterion. If the alt text is added at the end of the name, then it does not violate that success criterion anymore, but you still create a usability problem for speech control users. Another tangent, but general idea is avoid doing this as much as you can. At the end of his article, Adrian also recommends that you don't rely on the alt text on CSS generative content, especially for any kind of interactive control. Stick with HTML image or an inline SVG image. And so if the content is integral to the understanding of the page, add it in HTML. So does this mean that alt text for CSS generated as content is not useful? No, not at all. So some might say that since meaningful content belongs in HTML, and since you should only use CSS-generated content for decoration only, then you will probably never even need the alt text feature in CSS. I find the opposite to be true. Because you should only use or provide decorative content using CSS, and because that decorative content contributes to the accessible name of an element, you want to hide that element from screen readers so that it is not announced because it's decorative. So you want to hide it to improve the user experience. The specification is explicit about this use case. The alt text allows, the second paragraph below, allows purely decorative text to be elided or omitted in speech output by providing the empty string as an alternative text. This behavior would be consistent with how HTML images with empty alt text are treated. So when you provide an empty alt to an HTML image, the image is treated as decorative, and the presence of the image is not announced by screen reader users. And if you inspect the HTML image in the Chrome DevTools, you will see that the browser indicates that the image is ignored, right? The image also does not contribute to the accessible name of the element that it is contained in, which is expected. Similarly, when you insert decorative content in CSS, such as a redundant icon sitting next to visible text inside of a button, you can avoid announcing the icon as part of the accessible name by giving it an empty alt text. At the time of making of this talk today, the behavior of CSS-generated content with empty alt text is inconsistent across supporting browsers. Firefox does not count yet because it doesn't support it at all. In Safari on macOS, the image with empty alt is hidden, and VoiceOver does not announce the image, even when navigating the page using the virtual cursor. And this is the expected behavior. Thumbs up for Safari.
VoiceOver on Safari. Reload page. Heading level 2. Empty alt on reference image. Button. Button. You are plain text on page. Heading level 2. Empty alt on reference image. Plain text on page. Button. Button. You are currently on a button.
The image is not announced, which is good. Now, in Chrome, on the other hand, Chrome still exposes the CSS image as an image with no name. This means that the screen reader announces the presence of an image without a name. It does not expose the image as part of the button's accessible name, which is what you would expect, but the image is still exposed as an image with no name. And if you use VoiceOver using the virtual cursor, it's going to announce image with no name. Now, I got similar inconsistent behavior on Windows as well. JAWS on Chrome behaved well, just like VoiceOver with Safari, but NVDA and Narrator with Edge did announce the image when navigating using the virtual cursor. So the current recommendations concerning CSS-generated content are: avoid using CSS Studio elements for adding meaningful content. Stick with HTML. This is an always recommendation. And when support is there and behavior is consistent, hide decorative and redundant CSS content by giving it an empty alt text. Until then, you can insert the decorative content into a visual hidden span inside the element. CSS Studio content can be used to work around styling limitations for some native form controls, such as file inputs. I should probably skip this section if I'm going to make the last one. File inputs, I'll just try to go over quickly. File inputs are notorious for their limited stylability, and the fact that the button has a different label in different browsers makes it even less desirable to use. The CSS Studio Elements module level 4 defines a pseudo selector that enables us to style the file input button with no restrictions on which properties to apply to it. So using the file selector button pseudo element, we can change the button's colors, padding, background color, just like we can style any other button. But we still don't have control over the content of the button, the actual text label. CSS can't change an element's content, which means that the button's label and accessible name remain unchanged and different across browsers. Now, a while ago, I found a demo that suggests working around this by using the CSS before and after pseudo elements to create a pseudo label for the button and use CSS absolute positioning to place that label on top of the button's default label. So you end up with the same label in all browsers. Knowing what you know about CSS Studio content now, you know that this creates an accessibility problem. Not only will the name of the button now contain both the real label and the pseudo label, which is redundant, but there is now a mismatch between the visible label and the accessible name. If you use the before pseudo element to do this, you create a violation of that success criterion, label and name. And if you use the after, it does not violate it, but it creates a barrier for speech control users. So avoid using CSS Studio content to create fake button names. And always inspect the element in the browser DevTools and the accessibility tree to see how it is going to be exposed to screen readers. And the final way CSS can affect an element's accessible name is that it can completely strip an element of its accessible name if the element gets its accessible name from another element and that other element is hidden in a way that removes it from the accessibility tree. For example, if you have an input field and that input field gets its accessible name from a label element using the for and ID attributes, but that label is hidden in CSS using display none, which happens, the label is no longer rendered and its computed text is no longer used as an accessible name for the input. So the input is left with an empty accessible name. But, this is a good but. According to the specification, by default, assistive technologies do not relay hidden information, but an author can explicitly override that and include hidden text as part of the accessible name or accessible description by using ARIA labeled by and ARIA described by. This is one of my absolute favorite things about ARIA and using ARIA labeled by. This means that you can use ARIA labeled by to reuse the label as an accessible name for the input. If you ever have to deal with a project where you can't change the CSS, but you can change the markup, and if display none is used to hide an element, you can reuse it as a label using ARIA labeled by. In fact, this technique is better for some use cases than using the visual hidden utility class. So you might be wondering, why not just use the visual hidden utility class to hide the label visually, right? The reason is that I have so much I want to say. Since the label is not visible, and I'm trying to stick with the notes here just so that I don't go off too much. Since the label is not visible, and its presence is only for the purpose of providing an accessible name for the input, then hiding it from screen readers ensures that the label will not be announced by the screen reader when the user navigates the page using the virtual cursor. So if the label is hidden using the visual hidden utility class, it's still accessible. And if the user navigates using the virtual cursor, it's going to navigate through all the elements on the page, which means that it will announce the label even if it's not being shown. So you can avoid that. If you have an element in the markup and you have it there because you're a good developer and you're doing the responsible thing and you're using the label element, but you want to hide it, and so if the sole purpose of the text is to provide an accessible name to an element, and you don't want it to be read otherwise, hide it using display none, or my favorite, the hidden attribute, and then associate it as a name to another element using ARIA labeled by. Now, a lot of developers usually reach for ARIA label. They're like, if I don't want a visible label, I'll just use ARIA label. But ARIA label does not translate well, and it should be your last resort. The last section, I still have time. Equally important to understanding how CSS affects the accessibility information in the accessibility tree is understanding how CSS does not affect an element's accessibility information. CSS does not affect the semantic state of an element, and this is important. We mentioned earlier in the talk that the browser provides interactive behavior to native interactive controls, and that it updates and exposes the state of these elements when the user interacts with them, so that the user knows and understands the changes that changes have occurred as a result of their interaction. This is important because without a state, a screen reader user will not know if their interaction has actually resulted in any changes. If they keep pressing on a button and there is no way for them to know if that button has actually done something, it's confusing. So if an element controls another element, like if the element controls the visibility of another element, the element's state must be conveyed to the user so that the user knows when the result of their interaction has caused a change of content on the page. So if you have a button, and that button, when you activate it, it shows and hides some content, that button needs to expose that state to the user. Otherwise, they will activate the button and what happened? I don't know. You can avoid using JavaScript for some common UI interactions, like showing and hiding a simple popover when a button is focused or hovered. But this interaction is inaccessible to many users, not just screen reader users. For starters, when you show a popover on hover or on focus, it violates success criterion 1.4.13 content on hover or focus, which states that for content shown on hover or focus, there must exist a mechanism to dismiss the content without needing to move the pointer, hover, or keyboard focus. And the user must be able to move their pointer to the content without disappearing, which currently is not the case for these types of tooltips. And as far as screen reader users are concerned, there is no indication in the accessibility tree whatsoever that lets the user know that this button controls some other content when it is focused. And when they activate the button using space or enter keys, there is no semantic state conveyed that lets them know if their interaction was successful and something has changed. There is no shortage of CSS-only widget examples available online. A lot of interactive demos using CSS-only and the checkbox hack, and now the new has selector. Many of them use the checkbox hack to show and hide elements on the page. The checkbox alone is usually not enough to let the user know that it controls another element on the page. Again, the man of all tests, Adrian Roselli, has collected a few examples of CSS-only widgets and documented the accessibility problems with those widgets in an article that I recommend checking out for more details, just because I don't have time to go over them. Now, some CSS-only widgets use the checkbox hack in combination with the has selector to create no JavaScript modal dialogues. This is terrible. These widgets are particularly problematic not only because the semantic information to convey to screen reader users is practically non-existent, there is none, but also because the pattern they are used to create, which is the modal dialogue, requires additional keyboard functionality that is literally impossible to create using CSS. Modal dialogues must trap focus, and when they are closed, focus must move back to the element that opened them. And when they are open, the content of the page behind them must be made inert to ensure that the screen reader user can't access that content using the virtual cursor or other navigation methods while the dialog is open. So not only should you trap keyboard focus in there, but you need to make sure that the content behind it is inert and not interactive at all, because otherwise screen readers can use different navigation techniques to access that content, which they're not supposed to do. And when the focus is trapped inside the dialog, the screen readers must be informed that they are inside a modal dialog, so that they aren't confused as to why their focus has been trapped. For that, you need to use the dialog ARIA role. With the new popover API now available to us, we can use less JavaScript to create simple patterns that used to require JavaScript to be made accessible. For example, we can use it to create an accessible no JavaScript tooltip or disclosure widget. Hidde de Vries and Scott O'Hara have written a fantastic post that explains exactly what accessibility is built into the popover attribute and what isn't. If you ever intend to use the attribute for anything, this article is required reading. Now, one of the most important things to remember about the popover API is that popovers created using the popover API are always non-modal. If you want to create a modal popover, a dialog element is the right way to go. If you do use the popover API to create a modal dialog, like Yuna demonstrated in this demo a couple of months ago, then you still need to use JavaScript to supplement the dialog's expected keyboard interactions, because the popover API is not made for modal dialogues. So when you create it, when you have a button and use the popover attribute on that button, and the menu or the navigation opens, and you dim the page behind it, even though you've provided visual affordances to sighted users, but other assistive technology users don't know that the page was dimmed, and they can still access the contents of that page. Moreover, if you move your keyboard focus outside the navigation, it will move outside of it. It will move to the parts of the page that are dimmed and that are expected to be inactive, inert. So if you use the popover API to create something more complex like this, because the menu is modal in this case, which is indicated by the backdrop behind it, which later Yuna removed, it's no longer there, it must be exposed as a modal dialog to screen readers using the dialog role, and the content of the page must be made inert, and you will need JavaScript for both of those. Plus, you need to trap focus inside of it, and you also need JavaScript for that. So the popover attribute can be used as a great starting point, a helper, to reduce the amount of JavaScript that you use. But depending on what you use it for, you may still need to use JavaScript to add roles, update states, and manage keyboard interactions. When you build user interface elements, always ask yourself, am I creating the same affordances to screen readers and assistive technology users that I'm creating visually to sighted users? And how does this visual pattern affect keyboard users? Always look up how a pattern is supposed to be used. Tab through the page using a keyboard, check if everything is working as expected. Is the keyboard focus moving to some place it's not supposed to move to? If you remove the backdrop, which, like I said, Yuna did later, the menu no longer is no longer modal. So some of the semantic and interactive requirements are reduced. You no longer need the dialog role, and you no longer need to trap focus. But with this particular navigation demo, you will still have one problem, or one missing piece of accessibility. This problem can be seen on this website that uses Yuna's exact same source code to create a sliding navigation. When the menu is open, focus moves to the contents of the navigation, which is handled by the browser. But when focus moves outside the navigation, the nav does not close. And this is expected, again, because the popover API does not close the popover when focus moves outside of it. But because the nav does not close, keyboard focus moves to other focusable elements on the page that are obscured by the open navigation. This creates an accessibility problem, as it is in direct violation of WCAG Success Criterion 2.4.11, focus not obscured minimum, level AA, and mouthful, 2.4.12, focus not obscured enhanced level AAA, which basically just says if focus moves to an element, that element needs to be at least partially visible. And with the navigation, when it was open, it was obscuring the links on the page, which creates a problem. So to solve it, close the navigation when focus moves outside of it. That's all. And you still need to use JavaScript for that. So again, popover is a helper. Depending on how you use it, you may need to use more JavaScript. Now, with more powerful features available in CSS today, it is easier to respond to user interactions using CSS only, as Amit demonstrates on Smashing Magazine with a few creative ways to use the has selector for greater conditional styling. This is a great blog post, some great use cases in there. Now, while some of the techniques demonstrated in Amit's article are indeed useful in some contexts, they may also be problematic if they are used in other contexts. Again, it depends on where you use them, how you use them, what pattern you use them for. When making changes on the page, be aware of changes that cause a change of context. Otherwise, you might be in violation of Success Criterion 3.2.2 on input, which states that changing the setting of any UI component does not automatically cause a change of context unless the user has been advised of the behavior before using the components. If you have a button, if you have a select dropdown or anything, and when the user interacts with it, something big, a big change of context happens on the page, it can be disorienting. This is an accessibility problem. So what this success criterion is saying is make sure that the user knows what's going to happen next. Opening a new window, moving focus to a different component, going to a new page, even without page reload, or significantly rearranging the content of the page are examples of changes of context. Not all changes need to be conveyed. Like if you're only changing the background colors or the themes on the page, that's not a change of context. So when you use CSS to work your way around using JavaScript, always ask yourself if the visual affordances you're providing are also conveyed to screen reader users, and if the keyboard user experience matches those affordances as well. You may get away with creating some, very few interactive experiences without JavaScript, but you still need JavaScript to convey states, update properties and values, as well as update roles where appropriate, if you're using progressive enhancement to enhance something that's not interactive into an interactive widget. And you also needed to provide expected keyboard interactions where they are needed. I'm a huge proponent of progressive enhancement, and I'm also therefore a big proponent of the rule of least power, which suggests that you choose the least powerful language suitable for a given task. Or, as Jeremy Keith in a fancy shirt says, the rule of least power is all about evaluating technology, choosing the most appropriate technology for the task at hand. The key phrase here is the most appropriate technology for the task at hand. CSS is not the most appropriate technology for creating custom interactive widgets. Just because you can does not mean that you should. I literally got goosebumps. HTML carries, I don't know why, HTML carries semantics and meaning. And HTML controls, interactive controls, come with keyboard interactions built into them by the browser. For those that don't come with semantics and behavior built in, you will need ARIA and JavaScript to add them in. When you fail to do either of those, you create an inaccessible experience. I'm not saying don't use CSS's new powers to improve your workflow. I don't want to be a complete party pooper here. After all, this is a CSS conference. But I am saying that you must always think about how the code you write affects the user experience, and not just about how it can improve your developer experience. And most importantly, with CSS, you must also think about how it does not affect the user experience and what that entails. At the end of the day, the web platform was built with a user front and center, and it is our responsibility as designers of the web to stay true to the principles upon which this platform was built. If a trade-off needs to be made, always put user needs above all. Goosebumps. Thank you.
Thank you, Sara.
Thank you.
We even have time for questions,
Yeah,
which
I'm
is
surprised,
great.
actually.
Yeah, there's a number in the doc. We're only going to get through a couple, so you can find Sara afterwards as well. One that came in from a student. Lovely, lovely talk. So much in there. Thank you.
Thank you.
One that came in from a student that I wanted to get to right away. They said they hide elements absolute positioned and then off to the left, and large negative number. Is it better to hide with a clip path and height of 1 pixel, et cetera, the visually hidden, or is it just a different approach?
It depends. So moving elements of canvas is one of the different techniques, hiding techniques that are in that table that I showed earlier. So you can use it to hide elements of canvas. But like I said, it depends. What are you hiding? How are you hiding it? Not how. What are you hiding? Generally speaking, in the visual hidden utility class, I use it mostly for hiding text content. I rarely use it for hiding interactive elements because I generally avoid hiding interactive elements. But really depends on what you're hiding. You can move it off canvas if it's not going to affect accessibility. If you use, oh, okay, so clip path was about the visually hidden utility class. Yeah, it depends. It depends. As long as you get the result that you want, if you want the user, if it needs to be screen reader accessible and you're achieving that, then you're good. You can use either.
Great. There's another question here. If the websites you build don't have the target audience of people using screen readers,
how do you know? How do you know? You never know when someone is using a screen reader, and you never know when someone needs to starts using a screen reader. We're all prone, not prone, I don't know if that's the word. We're all at risk of being somehow disabled, either now, temporarily, situationally, in any case, and at any point in our lives. And not all screen reader users are blind. So I hear this argument a lot, people saying, But blind users don't use our websites. Screen readers are not only used by blind users. And like I said, you don't know who is using your website. So, and by making your websites accessible to screen readers, even though I mention screen readers a lot, but it's generally assistive technologies. So the same information that is exposed to screen readers is also exposed to other assistive technologies like speech control software. So you're benefiting more than just blind users. It benefits everyone. Accessibility makes web content inclusive to everyone.
Lovely, thank you.
Thank you.
And find Sara during the break with more questions. Oh, we do have time for one more.
Okay.
Great, we'll do that. I'll find one here. Actually, I think this is a great one to end on. Is there a list or a blog post, a collection of some sort where people can find the useful CSS snippets that you've been using, or any more information on what you talked about?
I was avoiding the shameless plug the entire talk because when you make a product and you start mentioning that product, people I don't want people to think that I'm just marketing my course. I've put a lot of effort, and this was just 50 minutes. The course is 15 hours of accessibility content. This is nothing compared to what you can find in the course. So my course, Practical Accessibility.
Thank you, Sara.
Thank you.